We're going to be continuing on with solving quadratics. So this one, we are going to be using the square root method. Now, the square root method works when we do not have your middle term, or if your terms are looking like this, where you have something that is perfectly square. So the first thing we want to do is try and isolate your term with your degree. So we want to get it alone and to one side. So first thing we can do on number 11 is add 8 to both sides. So we're left with -5 n squared is equal to -80. We want to keep n all alone and to one side. So let's get rid of its coefficient by dividing by -5. So the double negative will disappear, and then that division, we get to be 16. Now that n is alone, and it is even better, squared, to undo a square, we have to square root it. Now keep in mind, because our answer doesn't, or your equation doesn't start with a square root, what we now have to do when we square the other side is to account for both a positive and a negative solution. The reason for that is that your square root graph only has one solution, whereas your parabola has two. So we went from two solutions into one, so we miss a whole solution. So that's why we have to add your plus or minus sign. So n is equal to the square root of 16 is 4, and then we're adding on that plus or minus 4. Let's do it again for number 13. So one more time, we're going to add 2 to the other side. We want to isolate your term with the square. So we have n squared on one side. We have -90 on another. We can go ahead and divide by both sides by 5. So 90 divided by 5 is 18. Now we have a -18 here because our negative sign has not dropped off yet. So now that n is all alone to one side, we can go ahead and square root. Keep in mind, when we square root both sides, we need to account for the plus or minus sign. Now, depending on your instructor here, we have an issue. So some instructors will say, okay, well, we can no longer have a negative under a square root because, again, your square root graph from its parent graph, notice that there's no negative solutions. You don't have a negative x value here just based on its graph. So with that, they can say there's no real solution. However, another instructor might say, well, we can talk about imaginary solutions. Now, we won't deep dive into imaginary, but if we talk about imaginary solutions, I is really equal to -1. This is your imaginary number. So anytime you see a negative, so we'll just put it over here. We have the square root plus or minus the square root of -18. We can rewrite this to show that we have the square root of 18 and the square root of -1. We can separate the negative away from your 18. Now, this one this -1 can be now called I, just as your rule applies. Anytime you have a negative under the square root, you're going to take it out and call it I. That's as far as we're getting into imaginary solutions. Now, 18 has a perfect square in it. That's comprised of 9 and 3. There's a plus or minus out here in the front. So we can keep that out here. And the square root of 9 is 3. And the square root of 3 we have to remain. So all in all, we have 2 solutions. It depends on your teacher how they want you to write it. They can write it as such as 3, the square root of 3i, or 3i root 3. Again, there are 2 solutions here with the plus or minus sign. Or you might be tempted to say no real solutions. Now let's try it again with 12 and actually let's just do 14. Maybe you could do 12 alone. Now 14 has a different setup, and let's say we had one added step. Maybe we had something like this to begin with. So we have everything over here. We have this term that's squared, and we have this minus 72. So one method we could do is noticing that over here, we can't distribute, but we could expand it, and then we could FOIL it from here, and then see, is it factorable? And then we can solve it that way. If it's not factorable, we're going to talk about the quadratic formula here in a little bit. That's in part 3 or part 4. So instead, the roundabout method is, if this whole term is squared, what we can do first is isolate it. So we can add 72 to the other side. So now your m plus 8 is all alone to one side. Now that it's all alone, you've isolated it. We can then go ahead and square root both sides. This only works when your squared term, notice that it's being grouped, so this term is acting as 1 when it's all squared. That allows us to cancel it out, and it gets dropped with your parentheses. Now we can go ahead and reduce 72. 72 has a perfect square in it. We can have, well, if you wanted to break it up this way, 72, right? Factors of 72 that most students see are 8 and 9. 9 has a perfect square, which is 3, and 8 can be broken up into 4 and 3, not 4 and 3, 4 and 2. So square root of 4 is 2, root 2. And we can combine 2 and 3 because they're on the outside of your square root sign for 6 root 2. So this is not the largest perfect square in it. We could have broken up 72 as 36 and 2. 36 times 2, 36 times 2 will get you to 72. And because it's the largest perfect square in there, it goes to 6 and 2 remains. Always go with the highest perfect square if you can, but if you don't know some of your factors, you can always break it down as we did here. So plus or minus 6 root 2, m plus 8. Going ahead and isolating your m here, getting it all alone and to one side. We get m is equal to negative 8 plus or minus 6 root 2. We cannot combine your negative 8 and your 6 because 6 is directly attached to the square root of 2. This number is really representing the square root of 72 and will come out to be a number. So you have two solutions here, and that is how we get it.